Okay, so in last class we discussed about definite integration. Now the application of the definite integrals. The application of definite integrals is areas. Okay, na? Actually, when we are giving the geometrical interpretation of definite integral, there we discussed that the integration from a to b f of x dx is nothing but the area under the curve f of x and x axis and between the limits x equal to a and x equal to b. Yes. Now see, suppose the given curve is y equal to f of x. Now we are going to find the area under this curve in between x axis and ordinates x equal to a and x equal to b. Okay, now. So what is the area? The area equal to integration from a to b. Okay, integration from a to b f of x dx. Okay, now. Next, coming to here the curve is below the x-axis. If above the x-axis, then no problem, it is positive. See, remember, area must be positive always. Okay, na? If you get negative means you made a mistake there. Okay, na? So area must be positive always. So if you have some doubt whether it is positive or not, whether the curve is above the x-axis or below the x-axis, if you don't know, then simply put modulus. Simply put modulus. Then no problem. Okay. Now what is the area here? Actually the area is a equal to integral from a to b. Since it is below the x-axis, you have to write minus f of x dx, because integral a to b f of x dx is negative value. You will get negative value because this is the below the x-axis. So negative of negative, so positive. Okay. Otherwise you can write directly this is modulus integral a to b f of x dx. Okay, so without loss of generality, just use modulus for area, then you won't get any problem. Okay, now coming to here, see, some part of the curve above the x-axis and remaining part of the curve is below x-axis. So this interval split where the curve meets the x-axis. Okay, that is a to c, c to b. So then what is the area? So area a equal to a1 plus a2. So this area plus this area. Now this is equal to what is the area of this one? Integral a to c f of x dx plus, okay, now integral c to b. Actually this is below the x-axis. You have to write minus f of x. Okay, now. But without loss of generality, we write this is modulus and this also modulus of f of x dx. No problem. Then this is positive, this is positive. Okay, fine. Now coming to here. Here one curve is above the another curve. Okay, now. So f of x is above the g of x. Okay. Now the area of this one is a equal to integral from a to b, both curves above the x-axis. So no problem. Okay. A to b. Okay. F of x minus g of x, because f of x is above the g of x. So first we have to write f of x minus g of x. Suppose this is g of x, this is f of x, then you have to write g of x minus f of x. Okay. If you confuse, then what we have to do? Just put modulus. Okay. So dx, take a modulus, then no problem. Okay. See, actually here what happened means, see, area under the curve f of x. Area under the curve f of x means you have to get the area from this to this up to here, this total area. Area under the f of x means this total area. Area under the g of x means this one. You want area between this, so the total minus of this one, you will get in between part. Okay, so that is the meaning. Okay, so next model curves. Suppose the given functions graphs are like this. Okay, the given functions graph is like this. See, in this graph, from A to C, f of x is above g of x. But after C, g of x is above f of x. Okay, now the area of, so this is A1, this is area A2. So A equal to area of this region, A equal to A1 plus A2. So what is A1? A1 is area in between the curve f of x and g of x and x axis and ordinates A and C. So that is integral A to C. Which one is above? F of x is above. So f of x minus g of x. G of x is below into dx. Okay. Plus what is A2? Integral C to B. Which one is above? G of x minus below curve is f of x into dx. So if we have any doubt which curve is above the another one, then simply put modulus for individual areas, not total area. Okay. And now coming to here, see here we are going to find the area between the curve y axis and abscissa. A and B are the abscissa. Okay na? So the area A equal to integral. Okay na? So x dy from A to B. X dy. What is x? X is nothing but f of y. So this is equal to integral A to B f of y dy. See here limits are from y equal to A to y equal to B because the limits are on y axis. Okay? Fine. Suppose if this curve is left side of y axis, this side. Okay? Na? Okay, then it is the negative. Then you have to put modulus. Okay? Fine. Now coming to here. What is the area? Area equal to integral from A to B. Here which is upper curve. See, f of y is the upper curve. So look in this way. Okay, now look in this way. So f of y is the upper one and g of y is the lower one. So integral A to B f of y minus g of y, okay, into dy. So if you have any doubt, then put modulus. That's all. Okay. Now we will give some examples. Okay, how to find the areas of under the given curve. Okay, so let us give some examples to find the areas under the curves. Okay, now. So find the area of f of x equals sin x in the interval 0, 2 pi and x axis. Okay, now. So first draw the graph. How the graph of this function is. So sin x function we already discussed this in first year trigonometry. Okay, now. So sin x becomes 0 at pi, 2 pi, 3 pi, 4 pi, that is n pi. So this is pi and this is 2 pi and so on. Okay. So the graph of the side axis. So at pi by 2 it has maximum value 1, and again pi to 2 pi it is pi to 2 pi negative, sin x in first and second coordinate positive, so above x axis. Pi to 2 pi third and fourth coordinate negative, so below the x axis. Now you have to find the area, this part. You have to find the area, this one. Okay. So this is A1, this is A2. Okay. So the required area A equal to A1 plus A2. So what is A1? Integral from 0 to pi sin x. Our function is sin x dx from integral pi to 2 pi sin x dx. Here actually below the x axis, so you have to write minus sin x. Yes sir, we have to write minus sin x. Otherwise just simply put modulus for individual areas. Okay, right. Now this is equal to integral sin x is minus cos x from 0 to pi plus this is minus cos x from pi to 2 pi. Okay na? So don't forget modulus. Okay. And now this is equal to minus cos pi. So cos pi value minus 1, minus of minus plus 1, minus of minus plus cos 0 1. Okay na? Plus minus cos 2 pi. Okay na? Minus cos 2 pi minus 1, minus of minus 2 plus cos pi minus 1. Understood? Okay. So otherwise I will write one more step without confusing. Okay, I will write one more step. So this is equal to minus cos pi minus of minus plus cos 0. Okay, now okay, plus minus cos 2 pi minus of minus plus cos pi. So this is equal to modulus cos pi value minus 1, minus of minus plus, so 1 plus cos 0 1 plus this is minus 1 minus 1. So this is equal to plus 2, which is equal to 4. Okay, so next problem. So find the area between y equal to x square, x equal to 1, x equal to 2 and x axis, simultaneously x axis. Okay. Now first we have to draw the graph. Okay, y equal to x square. Y equal to x square is a parabola, open upward parabola. Okay, open upward parabola. So you learn this in 10th class. In 10th class quadratic equations. Okay, then you draw such a graphs. Okay, now. And now. So here the limits are x equal to 1, x equal to k, x equal to k is vertical line. So x equal to 1, where is x equal to 1? Here 1, okay na? This is x equal to 1. X equal to 2 is here, x equal to 2. Fine? Now this one and this one. Okay, so you have to find the area in between this. That means this area you have to calculate. Okay. Now see, this region is under the curve, which is y equal to x square, and between x equal to 1 and x equal to 2. So now the area will be, so integral from, what are the lower limit is 1, upper limit is 2. So 1 to 2 So under the curve, so this part, okay now, this part. So this curve is x square. So x square dx. Fine. Now this is equal to x cube by 3. X cube by 3 from 1 to 2. So which is equal to 8 by 3 minus 1 by 3. Fine. Which is equal to 7 by 3. Got it? Okay, so next problem. Find the area between y square minus 1 equal to 2x and x equal 0. Okay, now, so y square minus 1 equal to x, this is parabola. X equal to 0 is y axis. Okay, now you have to draw the graph of these given functions. Okay, now. So to draw the graph, first of all, where this function meets x-axis and y-axis. Okay, na? Now to find where this function meet the x-axis, you have to put y equal 0. Okay, na? So y equal to 0 implies, okay, na? Y equal 0 implies this is 0 minus 1 equal to 2x. So that implies x equal to minus 1 by 2. So the point is minus 1 by 2 comma 0. This is the point on x axis. Okay, na? Next, now where this curve meets y axis, then you have to put x equal to 0. If you put x equal to 0, now you can find where this curve meets y axis. So x equal 0 means y square minus 1 equal 0. Y square minus 1 equal 0 means y equal to plus or minus 1. So the points are 0 comma minus 1 and 0 comma 1. Okay, na? Fine. X equal 0 means y axis. Now draw the graph. Here and this one, okay, na? The graph is like this. Fine. Okay, just look at these two are similar actually. So this is minus 1, this is minus 1, this is 1, this is minus 1 by 2. Okay, and now we have to find the area, this area. Okay. Now we are going to find this area by using this y axis. Okay, na? That means variable is y here. So area A equal to integral from A to B means minus 1 to 1, minus 1 to 1. Okay, x dy. I am using the limits are y limits. So integral A to B x dy. So this is equal to integral minus 1 to 1. What is the value of x? Y square minus 1 by 2 dy. Understood? Now this is equal to 1 by 2 integral minus 1 to 1 y square minus 1 dy. Now this is equal to 1 by 2 into, so y cube by 3 minus y from minus 1 to 1. Okay. Now this is equal to 1 by 2. And now if you substitute 1 by 3 minus 1 minus minus 1 by 3 minus of minus plus 1. So this is equal to 1 by 2 into, so this is minus 2 by 3. This is 2 by 3. Okay, minus 2 by 3. Okay. Now this is equal to 1 by 2 into minus 4 by 3. So this is equal to minus 2 by 3. But actually the area should not be negative. Why we get negative value? Because see, this curve is with respect to y-axis. This is left side of y-axis. Okay na? That's why you have to use minus x dy. If the graph is right side to the y-axis, then you have to use x dy. But left side to the y-axis, if above x-axis y dx, below x-axis minus y dx. Left of the y-axis minus x dy, right of the y-axis x dy. So simply what you have to do? Simply put modulus. That's enough. So which equal to 2 by 3. Done. Okay. So next problem. Find the area between the curves y square equal to 4ax and x square equal to 4by. Okay. Find the area between y square equal to 4ax and x square equal to 4by. Okay. To find the area between these two curves, actually these two are parabola. Yes or no? This is parabola, this is also parabola. This is open right side parabola, this is open upward parabola. Okay na? So to find the area between these curves, first of all you have to find the point of intersection where these two curves intersecting. Okay. So let this curve 1, this one is 2. Okay. Now one implies squaring on both sides. So what you will get? Y power 4. Okay. Otherwise let us find first x value. Then it is somewhat comfortable. Okay, you can find any, no problem. You can find y value first, then x value. But generally, for us, comfortable is to find the x value first of all. Okay, na? So 2 implies x square equal to 4by. Squaring on both sides, what you will get? X power 4 equal to 16b square y square. Okay, na? Now this is equal to 16b square. What is the value of y square? 4ax. 4ax. Y square equal to 4ax. So this is equal to 16 4 ja 64. A b square x. So x power 4 minus 64 a b square x equal to 0. Fine. Now x into x cube minus 64 a b square equal to 0. Done. Now from this x equal to 0, one value, another one is x cube equal to 64 a b square. Then what is x? X equal to 64 a b square whole power 1 by 3. Which is x equal to 64 means 4 cube. So 4 into a power 1 by 3, b power 2 by 3. So x equal 0, one value. Another x value is 4 a power 1 by 3, b power 2 by 3. Okay na? Now if x equal to 0, now we have to find the y value. Okay na? So you can substitute in equation number 1 or equation number 2, no problem. Okay na? So x equal to 0, 2 implies what is the y value? Y equal to 0. If, then what is the point? Here the point is, let it be some point A, 0, 0. Now if x x equal to 4a power 1 by 3, 4a power 1 by 3, b power 2 by 3. Okay, so 2 implies, substitute this value in equation number 2, x square 16a power 2 by 3, okay na? B power 4 by 3 equal to 4by, okay na? Now y equal to 16a power 2 by 3, b power 4 by 3 by 4b. Good. Now 4 1 ja, 4 4 ja. So y equal to, see, 4 into a power 2 by 3, b power 4 by 3 minus 1. 4 by 3, a power m by a power n, a power m minus n. So 4 by 3 minus 1, which is 1 by 3. So here the point B, let it be B. What is the point? X value is 4a power 1 by 3, b power 2 by 3, and y value is 4a power 2 by 3, b power 1 by 3. Yes. Now we got the both point of intersections. We got both point of intersections. Okay. Now it is easy to find the area between these two curves. Now let us draw the graphs. Okay, so the graph of the curves. So this is y square equal to 4x. So y square equal to 4x graph is open right side. Like this. So this is y square equal to 4x. X square equal to 4 by y. Open upwards. Okay na? So this is y square equal to 4ax. So this is x square equal to 4by. Now we have to find the area, this area between the curves. You have to find area of this one. Okay. So this, actually consider this point as A, this point as B. So this is 0 comma 0, and what is B? So 4a power 1 by 3, b power 2 by 3, comma 4 4a power 2 by 3, b power 1 by 3. So this is the point B. Done? So now we have to find the area of this region. Now area A equal to, so integral from, I am considering the x limits. X limits 0 to, what is x limit here? Here the x limit is 4a power 1 by 3, b power 2 by 3. As I am using the x limits, we have to write here y dx, y dx. Okay na? Now this equal to integral from 0 to 4a power 1 by 3, b power 2 by 3. Now, so which one is above? See, this is y square equal to 4x. Y square equal, so this is the first curve, this is above and this one is below. So first I have to write this y square equal to 4x. From this, what is y? Y is root 4ax minus, now this is the second curve, below curve is second curve. From this, what is y? X square by 4b dx. Understood? So the above curve. So if you have any doubt, just put modulus without any confusion. Okay. So the above curve is y square equal to 4x. So y equal to square root of 4x minus second curve is below curve is y equal to x square by 4b. Okay. Now this is equal to integral from 0 to 4a power 1 by 3 b power 2 by 3. So 2 root ax, 2 root ax. Okay. So take a also outside. Take a also outside. Two root a into root x. Okay. Minus x square by 4b dx. Okay na? So now we apply the integration. So this is 2 root a. So root x power 3 by 2 by 3 by 2, x power n plus 1 by n plus 1 minus this is x cube by 12b, x cube by 3, 3 into 4b 12b. This is from 0 to 4a power 1 by 3 b power 2 by 3. Okay na? Now this is equal to 4a power 1 by 2 by 3 x power 3 by 2 minus x cube by 12b. Still I did not substitute these limits. 4a power 1 by 3 b power 2 by 3. Okay. Now substitute the limits. Upper limit. Now 4a power 1 by 2 by 3. What is the x value? 4a power 1 by 3 b power 2 by 3 whole power 3 by 2. Yes. Minus x cube 4a power 1 by 3 b power 2 by 3 whole cube by 12b. If you substitute 0, the total value is 0. Okay, leave it. Now this is equal to 4a power 1 by 2 by 3. Now this is 8a power 1 by 2. Yes, b power 1. Understood? 4 power 3 by 2. 2 square power 3 by 2 cube 8. A power 1 by 3 into 3 by 2. 3 3 will be cancelled. A power 1 by 2. B power 2 by 3 into 3 by 2. 2 2 3 3 will be cancelled. So B minus. Now here 4 cube 64 A B square by 12B. Yes. Now this is 4 8 32. A power 1 by 2 into A power 1 by 2, which is A into B by 3 minus. Okay. Now this is 4 3s are 4 16s are. Yes. Here 1B will be cancelled. Clear? Now this is 16 by 3 AB, which is equal to 32 minus 16, 16. So 16 by 3 AB. So this is the required area, 16 by 3 AB. Clear?